Welcome back to Behavioral Finance and FinTech. I'm Andy Kim, your Dr. Finance. Let's go through naive Bayesian classifier for text mining of a news article, how to quantify the sentiment shown up in your news article. Okay. Now, so machine learning technique, naive Bayesian is one of the supervised learning. Machine sees and machine does. What do they see? Well, what you do as a human being. In a training set, let's say there is 10,000 news articles or something like that. A part of it, you set it as a training set. Training whom? Training the machine, because machine sees what you do over this training set. Okay? And classify. How do you classify? And then learn based on this X number of articles. Let's say X is at least maybe 1,000 or so. And then N, in total, how many news articles you will do? We don't know. Many, millions, right? If N minus X is too small, this is what we call test set. The machine sees what you do in the training set and then extracts some kind of a probability, like prior probability and conditional probability, and then move down to the test set. With those probability estimation, what they do is computing posterior probability. Bayesian learning is done over there. And then using this test set of news articles, they apply the rule, the classification, to new data and then classify accordingly. Okay? And then if N minus X, this set is too small, there would be an overfitting problem. For example, if your training set is, let's say, 999,000 news articles, and then the test set is just 1,000 articles. First of all, you may question, if you given that you classified yourself for 99.9% of the news articles, why don't you just classify yourself with your human eyes, right? Why do you bring your machine down there? Number two question is like overfitting problem. Over here, you did so much on your own work so that the machine will blindly follow too much of your work without the necessary rigorousness. So overfitting will be a serious problem. If, on the other hand, if this guy is too big, then the accuracy will be very, very low, right? So if it's millions of news articles and then just 100 of them you just train, and then 1 minus 100, the rest of them is training set, test set, you're screwed, right? The machine cannot learn much from you. So this training set has to be big enough, Goldilocks big. Whereas the set rule, we don't know, okay? Goldilocks, just good enough. That's engineering. 안 되면 되게 하라 kind of approaches, right? Nothing is perfect anyway. So that's that. Naive Bayesian work is using the Bayesian technique, right? Bayesian machine learns, if we find such and such words as Kim Jong-un in a news article. Kim Jong-un 동지가 North Korea news, right? So it's more likely to be a news article about North Korea. Yeah, so that's that. Anyway, the problem. How would you set up those categories in your training set is the first problem. What if a totally new news category pops up in your test set? Over here, let's say, you never had COVID-19, right? But there, you happen to have COVID-19. You're screwed, right? So that kind of, when you demonstrate, the training set has to be large enough, right? And then you have to be good enough in your classification in the first place. Human trainer should be very thoughtful and consistent in training set. Which means, as an RA, if your job is to classify and demonstrate to the machine how to classify, it's going to be your slave labor that you have to do like crazy. It's going to be driving you crazy. You have to be consistent and very thoughtful in classifying. And you have to be very critical before you really classify. Is it correct to classify in this category as opposed to the other category? For example, China showed up. Is it an international politics category? Should it be an economics category? Yeah, so that's that. Time series wise, what if totally new kind? Curse of dimensionality is also a matter. So many words emerge, right? The unique words turned out to be what we call unigram. Okay, one word. Andy is one word, unigram. Andy Kim is a bigram, two words, right? Young-han Kim, that's a trigram, three words, right? The grams turns out to be the word, right? Unique word. Well, we have so many unique words emerging it, and then each unique word turns out to be a column in your matrix. Matrix? What the heck? A bag of words, we say. How would you make the machine recognize them as vectors and matrix? I told you, one news article is one row in that matrix, one row. And then let's say Andy, can you see it? Yeah, and Kim is here. One news article A, B, C. One news article may have Andy. If it has Andy, 1. No Andy, 0, 0. And then Kim shows up here, and then does not show up, does show up. Maybe Kim Jong-un is over there instead of Andy Kim. Jong-un, one word, let's say, just for simplicity's sake. And it shows maybe nowhere over here, but over there. Kim Jong-un. Oh my God. Each word turns out to be a vector. Yes, a vector. This is why 문과생 are screwed, right? 문송합니다. You're totally screwed, right? And then you have to learn about matrix algebra. Yes, if you are before graduation, I strongly suggest you to take the matrix algebra course. Matrix. All your words turned out to be. Language turns out to be matrix. We are living in these matrices. And then, lo and behold, the Matrix movie, the sequel movie is coming up again this year. Yes! That's a fun part, but the painful part is that you have to learn about matrix algebra yourself, right? Anyway, in your real life, for your real life, pulling out all these things. Yes. Now, example of naive Bayesian classifier. Well, training set, right? Two categories, let's say, in this example. I'm giving you one example over here. Classifying news articles into international news article versus non-international, 여지파, right? Whatever that is, non-international news. Let's say human, like you guys, RAs, read 10,000 news articles yourself with your eyes. And then you find that, ooh, this, okay, out of 10,000 articles, you classify 2,000 of them into international category and then 8,000 of them as non-international ones. Among the international news articles that you classified, 1,800 of them have the word China. Okay, China, the Donald Trump's pronunciation. China is here. And then among the non-international news articles, 800 of them have the word China over there. Okay. Now that's a training set to demonstrate to the machine how you classify those. Let's go to the test set. Okay, test set. Machine picks up a news article. Okay, a news article. I'll pick up a different news, the piece of paper over here. Okay, a news article from the test set. Oh, the machine says, I found China over here. Now, where should I place this one? International versus non-international. I have to estimate the posterior probability. Posterior probability, right? What is the posterior probability that belongs to international category? And then the posterior probability of getting into non-international category. You have to estimate those things, computing intensively. Right. So posterior probability, well, the prior probability of being classified into international is just what? 20%, right? That's because 2,000 out of 10,000. 20%, which means the counterpart of it is 0.8. Non-international probability prior is 80%. Good. Now you have to compute the conditional probability, right? What conditional probability? On condition that it is in the international category in your training set. What is the probability that this article contains the word China? Right? That's conditional probability over here, right? Given that you are in the international category, what's the probability that you are going to have China over there? That's 18 out of 20, 100, right? So that's 90%. Oh, very high percentage, right? The next is the conditional probability. On condition that this category is non-international, what is the chance that you are going to have the word China? Well, that's 800 out of 8,000. That's 10% only. Okay, I'm just making up these numbers, right? Now, once you have these conditional probabilities and the prior probabilities, you can compute the Bayesian posterior probability. What kind of probability is that? Well, given that you found the word China in this article, in the test set, what is the posterior probability that it belongs to international category? Okay, that's this guy over here, this ugly term. Wow, what the heck is that? In the numerator, what you see is the prior probability of 20% that comes from here. 20% belonging to the international category times the conditional probability. Given that this is international, what's the chance of having China word? 90%. That's the numerator. Denominator has this guy again and plus something else. What is that? That's a prior probability of being in the non-international category, and then the conditional probability. Given that this is non-international, what's the chance of having the word China? That's 10%. So if you do the math, you will realize that this is 69% posterior probability. So 69% of the chance it belongs to the international category. So I throw into that kind, right? I go for the category whose value is the maximum. Okay, that's the idea of Bayesian classifier. And then if you think about this number, 69%, that's familiar number, 69%. Where did I find that one? Well, that's exactly the number that we used in our discussion about the Bayesian posterior probability in the analyst example, in the, what is that? The Bayesian probability updating in our discussion in the class before, right? Go back to the class and then watch that one if you are not sure about it. I just switched and changed the wordings, but I'm using almost the same numbers over there, right? So that's that, which means it's going to be in your exam anyway. This kind of framework, Bayesian, is good to test you. Anyway, just like what I did before, I can do this kind of numbers, Bayesian probabilities, posterior probabilities, using this square and rectangle setting. All kinds of outcomes, the probability is sum up to be 1, right? The prior probability of being in international category versus non-international category, 20-80 split, 2대8 가르마, right? Kind of things, right? Okay, fine. Then what? For each category, right, we can compute the conditional probability. Given that this is international category, well, the conditional probability of having a China is 90% out of it. So the condition, what is that? This 18% is the probability of this guy, right? And then the remaining part is the chance that it's, given that it's international one, right? What is the chance that it's going to be not having China, right? That's red orange box over here. Out of the total, it is only 2%, but the conditional probability, it turned out to be 10%, right? So that's that. This multiplication is 2%. Now, looking at the right-hand side, what do you see? Well, the purple box is what? Given that this is non-international category, what's the chance of having China word in it? 10% only. So if you multiply this conditional probability by the prior probability, it's going to be 8%. So the area of this is 8, right? And then what about this sky blue? That's, what is it? Given that this is non-international category, what's the probability of having no China in it? That's what is that? The 90%, right? So conditional probability multiplying by the unconditional probability of being into the non-international category, 80%. Do the math, 72%. If you want to check your math, if you add these numbers, 4 numbers, you will realize it adds up to 100%. You're good. Now, Bayesian posterior probability. How do you calculate that? Well, that is based on these red and purple boxes only. So your denominator will be these 2. China is found, these 2. And then the numerator would be the number which the news with China belongs to international news category, right? That's this guy. Your Bayesian posterior probability is this guy divided by that. That's 69%, right? So in the previous example, in your rational, what's that? The expected utility maximization and then Bayesian probability updating. The example over there had the expert's opinion, right? Expert opinion. 쪽집게, the 전문가 says something, and then the guy's probability of getting it right is expert said 90% over there. That role is played by each different word. China over here, 90%, okay? And then prior probability, is applied as well. So you will see some equivalence relation going on over there. Okay. Now, anyway, so that's how we estimate the Bayesian updating posterior probability. Which category does it belong to? By looking at each different word, right, over there. Okay. Then the next becomes what? Well, why do we call it naive Bayesian? Okay, naive Bayesian instead of just saying Bayesian classifier, because each news articles possess many different words. I said bag of words. We just talked about China word category, right? Word and then categorizing it. But what if the news not just have China, but have other words? It could be Andy, it could be SKKU, it could be Andy Kim, whatever. The thing is, those appearances of words, right? China word versus Kim word, are they appearing independently of each other, right? Is there any other relation among these two, between these two, or among these bag of words? Okay? Of course, in reality, there will be some dependence. For example, Xi Jinping and then China word, okay? Xi word or Xi Jinping word and then China word. They are closely related. So it's not independent. They are very hugely dependent in reality. But let's forget about that dependence. Let's assume they show up independently. What a naive assumption. You are so away from the reality. That's why we call it naive Bayesian. But why do we use this naive approach? Naive approach enables you to use this multiplicative relations, multiplicative formation of your posterior probability. What the heck do you mean? Over here in your class note, you have to watch it, right? The posterior probability works like this. In your article, right? Let's say you pull out an article in your test set. First word is China, and second word is Andy, and third word is something else, and nth word turns out to be Xi Jinping, let's say. Okay, now what? Now what? Given that your word that you found out in these articles are these, what's the posterior probability that this article category should be international one instead of non-international? That's the posterior probability that we want to compute in the end. Holy cow. The posterior probability with China only, right, was complicated enough, right? Like box over box, like this. Box over boxes, right? But now we are trying to incorporate whole lot of words, like n different words, China and all the way down to Xi Jinping. You're screwed. But those naive assumption, if you put a naive assumption that the appearance of these words are independent of each other, makes your life easier. In that sense, that you can separate it out, China, and then its conditional probability of having international category like that. Multiply separately, blah, 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 and multiply separately by this, a conditional probability. Given that you have a word Xi Jinping, what's the, chance of getting into international one? So you can easily compute this posterior probability just multiplying blindly. And then one more time, you just have to multiply what? The category of prior probability of being in the international category. You remember this one before, right? So it makes your calculation a lot easier by being just naive, all right? So that's that. Yeah, it's not perfect. We all know, right? But it's better than having nothing. 안 되면 되게 하라. Oh, it's like a, that's the spirit of engineers, right? Now, naive Bayesian, you have many different categories: entertainment versus finance. Topics seem drastically different, easier to classify. But naive Bayesian classifiers have their own the problems as well. Buy versus sell, positive versus negative news categories. Well, what is positive to a certain companies must be negative news for the other companies, its competitors. Tesla positive news may be negative news to Hyundai Motors. Maybe. Okay? May not be as well. But how can you be internally consistent in that, right? You're in trouble, right? So that's very painful part of naive Bayesian classifier. Anyway, what's the research that used the naive Bayesian classifier? My professor in Minnesota, right? Professor Murray Frank. You Google search him, right? And then Murray Frank's research with Professor Antweiler in 2004, Journal of Finance, they studied the impact of the wisdom of the crowd in early 2000s, right? 21st century or before. Let's look at the Raging Bull, the Yahoo message board about stock investment. 종목 토론방, right? You Naver, you go there and 종토방 is there for you. And then, aren't you curious? What's the impact of this kind of discussion board in your stocks, right? They studied this one using machine learning, naive Bayesian technology, right? What did they do? Well, they set, the training set was 1,000 messages. And then test set was 1.6 million messages. 1,000 messages, what did they do? Well, they read, human beings read, which means their RAs, the PhD students, right, had to read it and classify it. Positive, medium, buy, hold, sell. Okay? Classifying them carefully, and then obtained and estimated all those prior probabilities and conditional probabilities. Now what? Bring these probabilities to the test set and run the machine. And then machines read in those texts, and then for each word they read, they compute. The machine computes the posterior probability of classifying into buy, hold, sell for each different words, for each different articles, right? And then try to estimate the maximum probability, posterior probability. So classifying those messages into the ones with maximum posterior probability. Right. So that's what they did. Okay. And what did they find? Well, messages. Positive messages predict positive stock returns. Negative messages predict negative stock returns. But statistically significant manner, but economically insignificant manner. What do you mean? After transaction cost, the return predictability is not there. Okay, it's not worth buying and selling those stocks based on the text analysis using Raging Bull, those short message board. Okay. Instead, what they found is that the volatility is significantly increasing. What is that about? Well, once you post a buy message to this 종토방 or message board, what can you expect? Those shall have antis, or antagonists will always come to you and challenge you. You say buy, that's bullshit. I believe this is a sell stock. Oh, and then the debate goes on, and then the disagreement happens, and buy sell forces takes off in the stock market as well, not just in this message board. Kibe, and then the stock battle goes on, right? So that the volatility increases with this message board. Okay, so that's what they found. At least this is important for hedge fund managers because you are vol traders, right? And then 종목 토론방 data crawling. How can you do it? You can go ahead and watch it in Korean market over here. Now, this is for early 21st century research, right? Early 21st century or 1990s late, right? Now, new research has come about the wisdom of the crowd. We will get there later on, okay? Thus, wisdom of the crowd in the message board, not just message board, but the seeking alpha in their stock discussion. Nowadays, it affects the stock price significantly. That's an interesting change in the reality. And then academic research gets updated with it. Now, the next paper that my professor Murray Frank found published, right, is this one. Frank and Sanati, Minnesota 후배 교수, like the graduated recently, and then my alumni. And then what they found in their research is they classified news article instead of short message boards like that. It's a longer news articles, 60,000 of them, and classified using naive Bayesian classifier, some positive news and negative news and news topics as well. And then what they found is this. For positive news, they find the overshooting temporarily and then reversing back substantially like that. Negative news, they find delayed response, just like PEAD, some kind of a drift going on like that. Why is that the case? Because of confirmation bias, 확증 편향. Whenever, let's say this is Tesla and positive news gets announced in the news media, what do you do as a stock investor? You believe that the Tesla is good. You believe that, Elon Musk is sexy, and then you have good news. I knew this is a great company. So you overbuy it. And then overshooting happens, and then it goes down later, subsequently. Overreaction in the positive side, but that's, asymmetric. And the negative news happens, the same confirmation bias takes place in your mind. Oh, I believe the Tesla is great. The negative news can't be true. So you are slow to sell it, slow to accept the reality. That's why there's a drift like this. By the way, he's, Murray Frank, his undergraduate major is a zoology, and then I guess, different kinds of animals you have to classify. Those naive Bayesian classifiers, I think that's a natural attraction for him. This methodology, right? Publishing into top journals with naive Bayesian. Very interesting research has been going on. Anyway, what I'm trying to say is that finance professors have, diverse background like this anyway, and then doing a lot of fun research as well. And then machine learning part, the next part in the video, I'm going to talk about a different approach in text mining. So wait for that, and thanks for watching. Bye.